It's the Advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'm a Papa Shell, but not what you think. Who am I root? Make it dead a leg sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around, McSkitty's got snitches. It's an insider threat, and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM Army, McGreedy will get caught from the 0x1 all the way up to the gods. And it is time. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsby. We are on a mission to save Christmas. And hey, if this is one of your first times checking out my video, whether on the live stream or the recording afterwards, here is what we are doing every single night through the month of December. We are working through TryHackMe's Advent of Cyber challenges, and I am going into them blind. So I have not looked at the rooms ahead of time, have not prepped them ahead of time. I've just started the machine, and I give you my raw reaction and my silly mistakes that I make as we work our way through it. Hey, a few announcements before we dive into things. Day 22 and day 23. So we are at day 19. So day 22 and day 23, a few days from now, there will not be a live stream, but here's why. I did the official walkthroughs for both of those days. So on day 22 and day 23, you'll still be able to watch the walkthrough on my YouTube channel or on the actual TryHackMe site. But those are my days that I was given to do the official walkthrough. So once again, day 22 and day 23, there will not be a live stream. Instead, you can watch the official walkthrough. And I just modified that walkthrough. Initially, when I did it before I made my Grammy nominated rap song Papa Shell. So I made sure to edit those videos. So now at the official walkthroughs, the first thing that plays is my, of course, Grammy nominated rap song known as Papa Shell. So we'll introduce the entire world to that incredible song. So just know that day 22 and day 23, I'm doing those official walkthroughs, so I will not be live on stream. The other quick announcement I want to make is when I'm done with stream, y'all, I don't know if any of you do VR. I got the Quest 2 headset. Geez, that would have been over a year ago now, and now I have the Quest 3 headset. And when I'm done streaming, me and my friend Nate are going to jump in VR and play some Onward, which is like a military sim in VR. It's a lot of fun. So just want to throw this out as an open invitation. Any of you watching live, if you have a Quest 2 or a Quest 3, or I don't think it's cross-play compatible with PC, but I might be wrong. But hey, if you have a VR headset, message me on Discord. Let me know. Would love to have you join me when we jump off stream. Even if you watch the recording on YouTube and you're like, hey, I have a Quest. Look, let's game together. Would love to play sometime. So just DM me. Would love to hear from you. Now, without any further ado, let's dive into our room for today. We are at day 19. We have made it 19 days in a row, which is amazing. I'm at, what's my streak right now on TryHackMe? 28 days. That is crazy. All right, Cryptoid miners sing volatility. We're going to learn all about memory forensics. The elves are hard at work inside Santa's Security Operations Center, looking into more information about the insider threat. McGreedy's going down. While analyzing the network traffic, Log McBlue discovers some suspicious traffic coming from one of the Linux database servers. Quick to act, Forensic McBlue creates a memory dump of the Linux server along with the Linux profile in order to start the investigation. Hey, what's up, The Flame? Good to have you here, my friend. I usually give a shout out to everybody in chat in the beginning. I forgot to do that. So all of you in chat, hey, thank you for being here. Let me get caught up on chat. So hello to Default Sec, hello to The Flame, hello to Justin, hello to Teraflops, hello to Dion. Let's see, what did Dion say? What's the cold, hard truth about getting into cybersecurity? I don't know. I guess so maybe I can switch back to my face. Let me answer that question a little bit, at least to the best of my ability. So over on YouTube, for those of you who can't see it, Dion said, what's the cold, hard truth about getting into cybersecurity? Well, I think one thing is don't get ripped off by all the influencers you see online that say, hey, in 2 weeks of you doing my silly course, you're going to make 6 figures, right? That's the biggest thing. And yeah, exactly what Justin said. There really is no such thing as entry level, but I don't want to gatekeep in that way. Like, it's true, there's no such thing as entry level, but I do think you can land a job in cybersecurity as your first IT job, even as a pen tester, as your first IT job if you put in the work ahead of time. The one thing I would say about cybersecurity and pen testing in particular, so let me just be clear, I'm a pen tester, so this is coming from the perspective of like, this is what I do for my day-to-day. Guys, I love this stuff. Like, this really is a passion of mine. I live and I breathe like pen testing and ethical hacking. It's so fascinating to me, which is why like I work full-time. I work a full-time gig as a pen tester, and then like most nights I'm back on stream doing it for free and continuing to learn. I was even looking at Twitch. I've streamed over 30 hours in the past month. That's in addition to my 40-hour-a-week full-time job as a pen tester. Also, in addition to the fact that I have a wife and 2 young kids, so when I get off work, I hang out with them until they go to bed. Once they're in bed, I'm back on my computer. So guys, I like live and breathe this. In some ways, I need a different hobby, but I love this stuff. And if you don't have that type of passion, I think it's hard to stay in the field and grow, because it takes that continual learning, way more than just getting a degree. It's a constant learning, and if you don't enjoy that kind of grind, cybersecurity and pen testing in particular, honestly, may not be for you. Hope that answers your question. Ready Set Exploit said, thank you for doing my day 19. Yo, sweet. So we have one of the room creators here. Well, hey, thank you for making the room, making all this content for everyone on here. Appreciate you being here. Tony said, what happened yesterday on day 18? Did you find the solution? Yeah, day 18 was quick. But I think you might be thinking about the Hack the Box stuff. So for those of you who weren't on stream yesterday, we first did Try Hack Me's Day 18 challenge, which was quick. I think it took 15 to 20 minutes. And then I attempted, so Hack the Box has a similar challenge called Operation Tinsel Trace or something, but it's all about incident response. And it was, way too difficult for me. I just have very little experience with that. I think I got 3 of the flags, but I was almost like 2 hours in, and then I called it quits. I'm interested in their Sherlocks, like on the Hack the Box platform, but it's just not stuff that I do, right? Like where I work at Rhino, we don't do purple team, we don't do blue team, we do only and straight pen testing. So like, I really love Hack the Box for the CTF, same with Try Hack Me. I'm just not that awesome at the blue team side of things. I think it's important, and I understand some of the basics. I've gone through much of the blue team content on Try Hack Me, and I have a sub to Hack the Box Academy. So I plan on doing their SOC pathway. Maybe that would be helpful, but I'm just not good. Let me rephrase it. I'm terrible at some of that stuff. So I got really stuck on their first challenge, but I got like 3 flags. So I'm going to count that as my win. All right. Enough of me chatting. Let's dive into this. Once again, thank you to Ready Set Exploit over in YouTube chat for making this room. Really do appreciate it. Learning objectives. Understanding what memory forensics is and how it's used in a digital forensic investigation. Understanding what volatile data and memory dumps are. Learning about volatility and how it can be used to analyze a memory dump, and learn about volatility profiles. I do know, like, for those of you who might be studying for Security Plus, I think that's what it was, way back in the day when I did Security Plus, I know they ask a little bit about this. I think it's Security Plus or it's CYSA Plus. I did both of those before I did like the OSCP, but I know they asked some questions about this. So hey, if you're doing any of that, make sure you lean in, or if you do incident response for a living or want to get in on the blue team side of things, pay attention. All right, so what is memory forensics? Well, memory forensics, also known as volatile memory analysis or random access memory forensics, or RAM, is a branch of digital forensics. It involves the examination analysis of a computer's volatile memory, or their RAM, to uncover digital evidence and artifacts related to computer security incidents, cyber crimes, and other forensic investigations. This differs from hard disk forensics, which, remember, we did that a few days ago on Avenue Cyber with, is it FTK disk? I'm blanking on the name, but we did that a few days ago on Avenue Cyber, where all the files in the disk can be recovered and then studied. Memory forensics focused on the programs that were running when the memory dump was created. This type of data is volatile because it will be deleted when the computer is turned off. And here's a big thing I want to highlight for you. If you're on the blue team incident response side of things, often when people are new to this, their first reaction when like a host is infected by malware is to turn it off. Do not do that, right? You should isolate it, maybe put it on a separate VLAN so it's not affecting the rest of your network. But one of the worst things you can do with an infected host is turn it off, because you lose a lot of this data that is in the RAM, in the memory. You can't do this when the computer turns off. So please, when you're doing incident response, do not hit that power button right away. make sure you are following a good process before you do that. Because of this, it will be deleted. All right, what is volatile data? I'm probably saying that volatile data. There we go. In computer forensics, this data refers to information that is temporarily stored. See that? Temporarily stored in a computer's RAM and can be easily lost or altered when the computer is powered off or restarted. This is one of the reasons Tails, if you've ever heard of Tails, is implemented in such a secure way. So if you've never heard of Tails, Tails is essentially a Linux distro that runs directly from a flash drive that routes all the trafficking through the Tor network. But the crazy thing about Tails is it doesn't touch your computer. It's all running off that flash drive, all running in this type of memory. And as soon as that flash drive is unplugged from your computer, it's wiped. It cannot be recovered. So that's where I believe it was Edward Snowden, back when all the leak stuff happened, he recommended Tails. There's another one that's similar but runs as a VM called Whonix. Whonix is pretty cool as well. What Whonix does, and I think I'm saying that right, is you actually have two VMs if you download Whonix. So you have the workstation and you have the gateway. And the gateway essentially acts as like your router. And so your workstation routes all of its traffic through the gateway, the other VM, which routes all of its traffic through the Tor network. So there's really no way for a threat actor, or anyone really, to expose your IP address, because even if they were to compromise your VM that you're using, well, they're probably not going to be able to escape it to your actual host. And even if they attack the router, that's literally just another VM. So if you're interested in some of that Tor networking type things, would recommend you check out Tails and check out Whonix. Those would be two good and relatively safe ways to explore that world. Obviously don't do stupid stuff, but it's the so-called dark web isn't as cool or as scary as YouTubers make it out to be to get more views. So if you want to check it out, those are two things that I would recommend. All right. Some examples of this data are running processes, network connections, and RAM contents. Volatile data is not written to disk and is constantly changing in memory. The issue here is that any malware will be running in memory, meaning that any network connections and running processes that spawn from the malware will be lost. Powering down the device means valuable evidence will be destroyed. Exactly what I was talking about. So what is a memory dump? Well, a memory dump is a snapshot of memory that has been captured to perform memory analysis. It will contain data relating to running processes captured when the memory dump was created. So what are some of the benefits? Well, it offers valuable benefits in digital investigations by capturing real-time data from a computer's volatile memory. It provides rapid insight into ongoing activities, detects stealthy threats, captures volatile data like passwords, and allows investigators to understand user actions and system states during incidents, all without altering the target system. In other words, memory forensics helps confirm malicious actors' activities by analyzing a computer system's volatile memory to uncover evidence of unauthorized or malicious actions. It provides crucial insights into the attacker's tactics, techniques, and potential indicators of compromise. Another thing to keep in mind is that capturing a hard disk image of a device can be time consuming. Then you have to consider the problem of transferring the image, which could be hundreds of gigabytes in size, and that's before you even consider how long the analysis will take the incident response team. And in addition to that, you also have a very clear chain of custody as you're doing this, because there's a chance it's going to go to court and the other lawyer is going to rip you apart if you mess with some of that stuff. This is where memory analysis can really help the RR team. Capturing a memory dump from any device will be much faster and smaller. Suppose we prioritize RAM over a hard disk image. In that case, the RR team can already start analyzing the memory dump for ILCs while beginning the process of capturing an image of the hard drive. Ready Set Exploit over in YouTube chat said the virus creatures on the animations are wearing Santa hats. Little detail there. Where? Am I blind? Oh, these virus creatures? Are those the virus creatures? Oh, yeah, they are. I was just thinking they were elves. That's awesome. We got our Christmas malware. All right, so what are processes? Well, a process is an independent, self-contained unit of execution. Oh, on the motherboard? Oh, hold up. I need to pay attention to this. Oh, that's awesome. I didn't even catch that. I thought you were talking about this weird looking alpha virus thing down there. Yo, TryHackMe did a really excellent job overall on this entire event. The animations for all of these tasks, and then just the creative naming scheme, and then the work by all the creators. really like bravo to TryHackMe. I've done, I think, 3 Advent of Cybers, and this is by far the best one. Not just because of my rap song. That's a big part of it in my opinion, but no, overall the rooms have been really fun. Okay, imagine your computer as a busy chef in a kitchen. The chef can cook multiple dishes simultaneously, but to keep things organized, they use separate cooking stations for different tasks. Each cooking station has its own ingredients, pots, and pans. These cooking stations represent what we call processes in a computer. This is crucial in memory forensics because knowing the processes that were running during the capture of the memory dump will tell us what programs are also running at the same time. We can categorize processes into 2 distinct groups. We have user process. These are ones, of course, a user has started. They typically involve apps and software users interact with daily. And we have background processes. These operate without direct user intervention. They have to perform tasks that are essential. A user process would be like Firefox, and then a background would be automated backups. We did this. I have my machine right here, so we got that pulled up. You can connect over RDP as well if you're VPNing in. I realize I haven't been checking LinkedIn. Let me check to make sure I'm not missing anything on LinkedIn. The LinkedIn chat, I always have to refresh, see if there's any comments. No, okay, we're good. All right, let's keep going. Volatility. Volatility is a command line tool that lets digital forensics and incident response teams analyze a memory dump in order to perform memory analysis. Volatility is written in Python, and it can analyze snapshots taken from Linux, Mac OS, and Windows. Volatility has a wide range of use cases, including the following: listing any active and closed network connections. That would be important to see, like, hey, is the computer reaching out to a C2 server? Is it communicating with some odd host? 2, listing devices running process at the time of capture. Once again, a really helpful thing. If we have, for example, a crypto miner running, we might be able to see that. Listing possible command line history values. Once again, huge. What was the user doing? What was someone on their machine? Do we have any clear text creds? Maybe to something that we can perform a hackback operation. Extracting possible malicious processes for further analysis. And the list keeps on going. For this task, we'll examine the memory dump of a Linux device. For your convenience, Volatility is already installed in the VM. We can look at the different help options using volp-h. All right, let's check it out. Make this big. Zoom in a little for you guys. We are volatility. Oh, wow, we got a lot of stuff. So I always like to look at kind of the help before I even read other stuff, so I have an understanding myself. It's easy to skim through these kind of things, but I think it's helpful to slow down and just look at it so you know what we're dealing with. So we have help, of course, debug, config file, all normal stuff, plugin. So this tells us we can load other plugins into this for help. We can do info, directory where cache files are stored. Got it. Sets the Olsen time zone. Okay, so for displaying timestamps. File name when we're opening an image. So we can use different profiles, it looks like. So if we want to analyze it from Windows XP, if that is what the snapshot is, I'm guessing we can do profiles there. So output format, we can write to a file so we can analyze it. Of course, we have verbose mode. We have some physical shift stuff, which is beyond my pay grade. Forced utilization of suspect profile. Specific KBR, address of header cookie. And then okay, so here's all the plugins. We have a whole bunch of plugins that we can do as we analyze things. So like print list of open connections. We can do command history, looking at command history, looking at command line arguments. What else do we have here? Dump passwords from memory. Dump hibernation. So that could be used by a red team then. Dump some passwords from memory if we get access to a PC while it's running. Can we pull some creds out of RAM and maybe reuse them? Scan for various objects. Wow, it looks powerful. I mean, all of these different plugins that we can use as we analyze stuff. Really cool. I've never used this before. Ready Set Exploit said some commands might take an extra second. The casualty of using Python on just 2 gigabytes of RAM. Oh yeah, that is rough. That's the default size for TryHackMe VMs, right? Like I've created, I have a few machines, official ones that will be coming out. Let's see, I have CyberLens. I think CyberLens is first, Hack Smarter, and I just created a new one based on some CVEs I discovered recently called Silver Platter. So those are all going to be official releases on the TryHackMe platform, but for every single one, I had to have TryHackMe bump up the resources because like as soon as I would try it, like the first two are Windows, so those just like broke. Even my Linux one, it wouldn't run properly. But it makes sense, they host it for free. But yeah, I agree. For each of the ones I have created, I had to have THM bump up the resources, which they did graciously. Okay, at the time of writing, there are two versions, Volatility 2, which is built using Python 2, and Volatility 3, which uses Python 3. There are different use cases for each version. Depending on this, you might choose either one over the other. For example, Volatility 2 has been around for longer, so in some cases it will have modules and plugins that have yet to be adapted to Volatility 3. For the purpose of this task, we're using Volatility 2. Before we start analyzing the memory dump, let's go into what profiles are and how Volatility uses them. And I was curious about that, I saw that. So profiles are crucial for correctly interpreting the memory dump from a target system. A profile defines the OS's architecture, version, and various memory specific to the target system. Using the appropriate profile is crucial because different OSs and versions have different memory layouts and data structures. Volatility comes with many profiles for the Windows OS, and we can verify this using volpy-info. Is that different than the command I ran before? Oh yeah, we have a little more information here. Here's everything it's talking about. So look at all these profiles. We got Windows Vista, of course, the greatest Windows operating system ever created in all time. And we got Windows 10, Windows 2003, we got 2012, we got Windows 7. Curious which Windows y'all grew up with. Mine was Windows XP. I used a little bit of Windows 95 and such, but when I really got into computers, XP is where it was at. That's when I really started looking into some of this stuff. What about y'all in chat? Anyone older than XP when you started getting into computers, like really getting into them? I did Windows 95 really as a young kid, just playing some computer games, but XP, you know, playing old school RuneScape. I remember one of my first experiences with scripting, like making things pop up, was a Habbo Hotel. Anyone remember Habbo Hotel? I remember downloading some program and you could script stuff out. So like you had special furniture and stuff. Amazing stuff. Windows 95 for Ready Set Exploit Charles is Windows 98. Amazing. All right, did you notice there aren't any Linux profiles listed? Profiles for the Linux OS have to be manually created from the same device the memory dumped is from. Here are some reasons why we typically have to create our own profile. Linux is not a single monolithic OS, but rather a diverse ecosystem with many distros and configurations. Each distro may have different kernel versions, configurations, and memory layouts. This variability makes it challenging to create a one-size-fits-all profile for Linux. Makes perfect sense. Unlike Windows, which has more standardized memory structures and system APIs, Linux kernel internals can vary significantly across different distros and versions. This lack of standardization makes it difficult to create generic Linux profiles. And finally, it's open source, meaning that source code is readily available for inspection and modification. This leads to greater flexibility and customization, but also results in more variability in memory structures. Creating profiles is out of scope for this room, so for your convenience, a profile is already here in a directory called that. So let's go ahead and check that out. Was it desktop? And I think that's where it's at. All right, there is our profile.zip. To use the profile, we have to copy it to where Volatility stores the various profiles for Linux. This command will take care of this for us, and I am just going to copy and paste it, but let's go through it for those who might be new to this. So CP, that just means copy. And because we're in this path right here, we don't have to specify the path because we're already there. So here's what the command is doing. We're saying, hey, we want you to copy, and we want you to copy this file, and we want you to copy it to our home directory, .local lib python2. So if you are used to Windows and Linux, these are kind of like folders, directories, but kind of like folders if you're used to Windows. Python 2.7, site packages, volatility. So we're just copying it into where these plugins are at. And then we're going to run this and see if our profile is set. So let's go ahead and do that. I'm going to copy and paste it. We'll Control C, jump over here. And from a terminal, if you hold Control Shift V, it will paste it in into a terminal. Okay. And now we're going to see if it works. So we'll do vol.py info grep. So this command right here just means we're piping it out. So we're saying, hey, take the info command, and now we want to grep or search specifically for Ubuntu, right? And there it is. We have it. So we successfully loaded the profile. Good work, team. All right, if you're curious about how to create it, you can see this article. Let's just glance through this a little bit. So how do we do it? Oh, so we use a Docker container. We get our kernel version. We generate a profile for Volatility 2. Kernel detection. We run a Docker container that matches the target OS. And then we install the packages. And then we create a zip archive containing the dwarf file in the system map. And then we have the zip archive containing the correct profile. Okay, so I mean, it's not super difficult, but definitely out of scope for a Try Hack Me room because it requires quite a bit to do, like getting the Docker and everything running properly, but cool. All right, memory analysis. The file linux.mem contains the memory dump of the Linux server we are going to analyze. The file is located in our home directory. For Volatility to begin with analysis, we have to specify the file, which we saw that when we were looking at the help command, with the profile flag. We can use the H flag to look at all the different plugins we can use to help with our analysis. Okay, so then we're going to walk through those ones. Let's go ahead and run this command, though. Where's the memory dump at? In our home directory. Or does it mean like desktop? Oh, evidence maybe. Oh yeah, I was literally in the folder. I'm silly. Okay. So then I suppose we're passing it Linux, and then it's saying, hey, what are the Linux plugins that we can use to do this? So let's look at these a little bit. We have image copy. We can dump Lime file format information. We can check for API hooks, print the ARP table. Let's see which ones that I think would be most interesting. This I think would be helpful. Recovering bash history. This would probably be helpful as well. Sharing credential structures, maybe. Check file operations. I'm just skimming this real quick. This is probably helpful. This files. This might be helpful as well. Something like this would be helpful. Cool stuff. And hopefully what I'm showing some of you who are doing Advent of Cyber, when it comes to events like Advent of Cyber, I think one flaw of all of us, of humans in general, is we try to rush through the room. Like we think, hey, the end goal is let's get the final flag, let's answer the final questions to say, look, we did it. We finished with day 19 or whatever day it is today. But you're missing the point of it, right? The goal isn't to rush through and get the flags. The goal is to learn. So when you're doing rooms like this, do what I'm doing right now is slow down and like read through it a little more. Read through the articles that the author points you to so you understand a little more about what's going on. The goal isn't to get the final flags, and the goal is to learn. So just my big encouragement, don't rush through this material. Slow down and seek to understand it, play around with it a little bit. I think that's helpful. Okay, so different plugins. So which ones are we going to use? The history file, I think that's the one that stood out to me. The history file is a good place to start because it allows us to see whether there are any commands executed by our malicious actor while they were on the system. To examine the history file for any such comments, we can use a Linux bash plugin. The command will take a little less than a minute to finish executing. All right. So that was this one up here, right? That's the same one? Yep. That's the one that stood out to me, Linux bash. A little less than a minute. Well, chat, how's everybody doing? Teraflop said they began with Windows 95 as well. Find Alps is on brand for tasks. Okay, cool. We'll get to it. And check out LinkedIn, make sure I'm not missing anything over there. Don't think I am, at least no chat. And I usually say this in the beginning, but for those of you who are unaware, we are live right now with 3 different platforms. You're live on YouTube, Twitch, and LinkedIn. So whichever platform you prefer watching on, feel free to join on that one. Okay, well, it's done here. So let's walk through this. What did the user do? Well, they switched over to the root user, which is what that sudo su is. And then as the root user, they cloned this lime, and they went over to the source. They made it, so they made the binary. And then they were looking at their bash history. Clearly a hacker because they're using vi. Then we're looking at home Elfie. And then we're becoming root again. Looking at home Elfie. Oh, these are probably just different times if we look at the times, maybe. Bash history. Oh, we have some credentials here. So we have credentials for MySQL, which standard syntax MySQL, U is our user, and then P, and we're passing it the password. And then we're doing ID, and then we have this toy miner. Okay, so that's interesting. Coming from this IP and toy miner, we're saving it as a miner. It sounds like that might be a malicious cryptoid miner that the task talks about. And then we're running miner, right? Interesting. Let me look at questions. I'm guessing some of the questions at the end are going to ask us about that. Let me see if I'm right. What is the exposed password we find in the bash history output? That's this one right here. What is the PID of the miner process that we find? Okay, so we don't have that information yet, but we did find that. So what are we looking at? The PID of the process, the MD5 hash, the MD5 hash of the MySQL server. Use the command strings that... What is suspicious URL? I'm guessing it's that one, isn't it? Oh, maybe not. So we have a dot in it. After reading the Elfie file, what is the location? Okay, so that's the next one we're looking for, the PID of the miner process. And I'm guessing there's a plugin that's going to dump like the processes that we're running for us, and that's how we're going to find that. That's my guess. Okay, so what did we discover? Well, we found the root password. Yep. This means the malicious actor most likely saw the MySQL command and had access database. Gotcha, that makes sense. We also identified the miner command, which the ELF analyst says we didn't use. This tells us the malicious actor used curl to download the toy miner file and save it to the O parameter as a file named miner. We can also see the malicious actor executed the miner file using miner command. Now that we understand the malicious acts are executed, we can look into the system's running processes. In memory forensics, examining running processes is a fundamental and crucial part of analyzing a system's memory dumped. Analyzing running processes in memory forensics can be highly effective in identifying anomalies because it provides a baseline. For example, we know that the miner plugin was executed, so let's see what that process looks like. To examine it, we can use a Linux PSList plugin. And how do we save it to an output file? Because I think as we look at that, that might be helpful. I mean, I guess the room doesn't call for it, so maybe it's not needed. Let's just look at it. Linux PSList. I just remember seeing them the help command, because then we could like grep and do things through it as we analyze the different processes, but it should be easy enough to look at them here. Oh yeah, we can already see it here. So what's this showing us? Well, we can see the processes that we're running. We have the offset, so that's the memory address of the process. We have the name of the process, the process ID, UID, GID, DTB, and then the start time. And I think the question, one of them was the process ID of the miner process that we found, which I saw that at the bottom here. the miner process right here. 1000. Wait, what? I might be looking at the wrong thing. Oh yeah, I am looking at the wrong thing. 10280. There we go. What is the MD5 hash of the miner process? So I don't think we have that information here. So I'm guessing there's going to be another plugin that we use for that purpose, possibly. Let's see if I missed anything. Yo, what up, Zach? Thanks for being here, my friend. Process. Here we go. As you can see, the plugin doesn't just list each process name, it also gives the PID, the parent PID, helps determine what is often referred to as a parent-child relationship between processes. There are only two anomalies that we'll quickly identify. The ELF confirmed they didn't execute the miner process. Based on the program name, our initial assumption is that we may be dealing with a crypto miner. A crypto miner, short for cryptocurrency miner, is a computer program or hardware device used to mine cryptocurrency. Cryptocurrencies are digital or virtual currencies that use cryptographic techniques to secure and verify transactions on a decentralized network called the blockchain. And everybody on Discord can help you, get rich off crypto, the crypto bros. Zach said, got my Network Plus tomorrow. Dude, good luck. Network Plus is really good cert. I remember when I did it. I think it's underrated. It gives you really good networking knowledge. You have to memorize a bunch of ports, which is helpful when you are doing pen testing because you can look at a port and you know what service it's likely going with. So good luck. Let us know how it goes. And then the MySQL server appears to be benign, but this is misleading. Oh, so I didn't even catch that. Let's look at that ourselves. So we have MySQL server. And yeah, that's not the name of the process. It's MySQL D. The ELF analyst confirmed that they didn't execute this either. Given that the PID of the process is different from the miner process, the process did not spawn from the miner directly. Is it? Oh, yeah, it is. We would like to know more about these. A good way to start is by examining the binary of each process. We can do this via process extraction. So a good way to understand what a process is doing is by extracting the binary. This will help us analyze its behavior using malware analysis. We also want to extract the binary of the process as a form of evidence preservation. To extract the binary of the process for examination, we can utilize the Linux procdump plugin. We just need to create a directory to indicate where we'd like the extracted process to go with the make dir extracted command. Then we utilize the D flag to tell Volatility where to place the extracted binary and indicate the process's PID with the -B flag. Creating a separate directory doesn't just help us stay organized, it's required by Volatility in order to avoid errors. Based on our file history and running processes findings, we are now going to extract the miner and MySQL binaries using the commands shown below. So we're going to make a directory called extracted. And then what are we doing? Well, we're doing our same thing we've been doing. We're specifying our profile, and we're doing Linux procdump -D, so saying, hey, we want you to put it in the extracted directory we just created, and then we're giving it the PID of the file that we found, right? So the PID, we'll see it here. So the PID of miner is the 10280. And then we'll do MySQL server next. The fake. The imposter. MySQL server. Okay. And now the next one is 10291. Okay, and there we have them. Okay, so that's everything I just did. Replace the PID. Yep, I did that. We have successfully extracted this. Oh my goodness, I cannot talk. We have successfully extracted the suspicious programs into the extracted folder. Having heard all the commotion, McSkitty offers to help with the investigation by taking over the operations threat intelligence task. McSkitty needs the MD5 hash of each extracted binary, which we can provide with the following command. So built into like every Linux distro is this MD5 sum, and then we just specify the binary to get the MD5 hash. And the reason for that, if you're new to MD5 hashes, then we just know that, hey, when we're working with this program, we can hash it again and make sure nothing has changed. So MD5 sum minor that. There we go, an MD5 sum MySQL. Okay, and I'm guessing I'm going to need these hashes for questions. I think it asked about these, so let's double check. Minor process, done. And then we have the MySQL process. Done. Okay, in the meantime, remember what he learned from the Linux forensics room. Forensic McBlue wants to check for persistence mechanisms that may have been planted by the malicious actor CryptoMiner, and I believe that was yesterday, right? Persistence mechanisms are ways a program can survive after a system reboot. This helps malware authors retain their access to a system even if it's rebooted. Good old McBlue remembers that a common persistence tactic is via cron jobs. While there isn't a plugin to view cron jobs, it can review them by enumerating for cron files. File extraction. As stated above, we want to look at any cron files that may have been placed by the malicious actor or CryptoMiner. This can help us identify if there are any persistence mechanisms at play. For example, is the MySQL server process we found before part of a persistence mechanism? But how can we enumerate files in the server? Well, we can utilize the Linux Enumerate Files plugin to help us with this. The benefit of the plugin is to help us review any files of interest. The plugin's output will be too large, so we can utilize the grep utility to help focus our search. So what are we doing? We're passing our profile. We're using this plugin, Linux Enumerate Files, and then we're grepping for cron, and -I means so it's case insensitive. So that's our command. Did I do something wrong? Oh, I'm in the wrong folder. Silly Tyler. Go to the right folder where the Linux memory process is, and maybe it will work. Give it a minute on our 2 gigs of RAM. That's going to show us some of this stuff. We'll see what might be here. Let's look at our remaining questions. So we're going to use this command, strings extracted. So, we're going to look at strings from it. And grep for the HTTP, got it. After reading the Elfie file, what location does the MySQL server process dropped in on the file system? So that must be later on. Come on, I believe in you, volatility. I suppose it says the output is so large, so it's going to take a while for it to print the output and then grep through it. There we go. It's doing its thing now. We can read ahead a little bit while we wait for that. So it says we identify the cron tab located in var spool cron tabs Elfie. Right here. We speak to the ELF analyst who confirms they didn't have any cron jobs set up on this server. We can now extract this file by selecting the inode value, the hex-like value located to the left of the file name, using the O option, and name our file during output and place it inside a previously created extracted directory. And I'm guessing this, since we're doing we're all working on the same file, this number should be the same for all of us. Okay, and ours is done anyway, so we can see our cron tabs Elfie right there, and then we have this right there, E8, 0E8. Yeah, it's the same in the task as well as right here. Oh, right there. This one right there. So then we're doing Linux find file -AI. We're passing it this, and then we're putting it in our extracted folder and calling it Elfie. I got you. Okay, there's our Elfie file. Go ahead and examine the contents of the Elfie file using cat to understand how the MySQL server's process was placed. Do not edit this file. Edit the master and reinstall. Installed on Monday, October 2nd, 2023. So it's coming from var temp.system python 8 updates MySQL server. So that's how that was installed. I got you. After reading the Elfie file, what location is the MySQL server process dropped in on the file system? I think that's just the var temp. That is the location. There we go. And now we're going to look at strings. And I actually want to do more than just looking at HTTP. Like what do we all have in that file? That's the miner file, right? The PID from question 2. Yeah, so the miner file. Okay, so we have some craziness going on. Let's just glance through here, see if anything stands out to us. I won't spend a whole lot of time on this, but there'd be way better ways of doing this in strings. But hey, when you have a binary, one easy thing to do is just check strings, see if there's any readable text. Sometimes, like if you're doing an actual pen test, like I do mobile app pen tests every once in a while, there's something called MobSF that will do a lot of this for you. But sometimes you can find like API keys and stuff being stored in strings. Oh, it looks like our history. The history on our terminal doesn't remember much, and it might be if I add more, I'll crash the terminal. So we might just have to grep for stuff like what it's asking to get the URL. So we'll do that. We'll just grep for HTTP. Okay, so what do we see with HTTP? We have our head invalid lookup, so of course that's not going to be it. But as we look through here, we do discover this, the McGreedy secret C2 THM. So we know that's going to be our malicious file. If I could copy it, that would be a good starting point. All right, we'll copy it from over here, and I'll just fix it up. Oh, I have to defang it. So we could manually defang it, but I'll introduce you guys to CyberChef. For those who maybe haven't used it before, CyberChef is a cool little thing. We can look for defang like that, and then we have the defanged URL right there. Actually, we need to go back to that. There we go. Have I done this room? I don't think so. No, so if you want to get more into volatility, here it is. I'll have to check this out. Maybe we'll do it on stream sometime because it seems like a really, really cool tool. All right, can I run these binaries? Does it do anything if I run it? I'm going to kill the VM. It's running. It would appear. So it's a real file. I wonder if that has anything to do with like the side quest. If you do more with that binary for the side quest, dig into it more. which obviously I'm not allowed to stream the side quest. I'm also not doing the side quest, so if I accidentally stumble across a side quest, I don't think that's considered breaking the rules, right? How do I just want to look at all of strings just for fun. How do I set my history so it contains more, so it shows me all the text? Well, I guess I could just do oh, no, that doesn't work, does it? Oh, no, it does. Okay. So we can look at it a little bit in nano and see what's going on. We have some Gopher stuff. Bash RC. That's not found. We have our invalid lookup. We can search again. There's that McGreedy. So we could own this in nano. We see the McGreedy thing there. And that's the only other thing there. Is he anywhere else? No. All right. Interesting. Oh, Ready Set Exploit said it won't run because the VM has no internet connection. Oh, true that. That makes sense. I'd have to run on the attack box. Oh, well, I'm not going to spend a whole lot of time looking at the binary, but it would be a fun little side project. Once again, curious if this seems like something that you would do something with this for the side quests. And I do want to check out the side quests when they're allowed for streaming. I haven't looked at any of them now, mainly just because I'm busy that when I'm on stream. Oh, that looks like a base 64. Oh, there's an R. Is that a private key? Is that like a private key to get into the C2 server or something? Or no? Or is it just like a server certificate? Now I'm kind of curious. We can see some of what was running on here, like what API calls it's using. What if we upload this to VirusTotal? I don't have my VM open, so I'm not actually going to do that, but some interesting side stuff here that might be fun to learn from. All right. Let's go back to the room. We have completed it, so took me 50 minutes. I think someone in chat said this will be a short stream. It's only a short stream if you don't slow down and follow rabbit holes and seek to learn. So that was a full 50 minutes learning about memory forensics and volatility and crypto miners. So thank you, everyone. We have made it through 19 days of Advent of Cyber. So really do appreciate you taking the time and going through this journey with me. Want to say a special thank you to Ready Set Exploit over in the chat for making this room and teaching all of us about memory forensics and volatility, if I said that correctly. And hey, as usual, I will be back tomorrow evening doing the same thing, but do just want to remind you, days 22 and day 23, I will not be live streaming because I made the official walkthrough. So you'll be able to find that walkthrough on my YouTube channel, as well as on the Advent of Cyber Try Hack Me page. You'll see my video up there. So make sure you check those out for day 22 and day 23. But I will be back tomorrow, same place, same time, as we continue our mission of saving Christmas. So thank you everyone for being here. I will see y'all in the next one. Peace.